Alright, you're welcome to today's video, and today we are going to be looking at relative molecular mass. So we're going to be looking at the relative molecular mass. We're going to be taking calculations in relative molecular mass. So in exams, there are some calculations that you can never escape, and those are the things we are going to be looking at today. Now, first, before we go into our practical questions, let's look at the meaning of relative molecular mass. Now, relative molecular mass is represented as MR. If you check very well, the M is capital and the R is small. That's relative molecular mass. In some places, you see it represented as relative molecular mass. So it's either represented as capital letter M and small letter R, or capital letter R, capital letter M, capital letter M, relative molecular mass. So anyone you see, just know what they're talking about is relative molecular mass. So the relative molecular mass of an element or a compound is the number of times the average mass of one molecule of it is heavier than 1/12 the mass of one atom of carbon 12. Now let me explain what that means. Carbon 12 here is always taken as our reference point. It's always taken as our reference. So you are comparing an element or a compound with the mass of one atom of carbon 12. So the average number of times, the the mass of that element or compound is heavier as 1/12. 1/12 is 1/12. As 1/12 the mass of one atom of carbon 12. That is called the relative molecular mass. That's the relative molecular mass. So the average number of times, the mass of an element or a compound is heavier than 1/12 the mass of one atom of carbon 12. That's the relative molecular mass of that compound. But that's not what we are going to be using in our calculation today. So I have a series of examples that we're going to use to solve what relative molecular mass is actually talking about. So let's take the first example. Now I would like you to pay great attention here. It says calculate the relative molecular mass of limestone. And we're given the molecular formula of limestone as CaCO3. That's calcium trioxide carbonate. Calcium trioxide carbonate, that's limestone. So we're asked to calculate the relative molecular mass of limestone, and we're given the relative atomic mass of calcium as 40, the relative atomic mass of carbon as 12, and the relative atomic mass of oxygen as 16. Now we are asked to calculate the relative molecular mass. Now anytime you're asked to calculate the relative molecular mass, just like I told you, you can use this to represent relative molecular mass. The relative molecular mass of a compound of an element is the summation of the relative atomic masses of the individual elements that make up that compound. Now I take that again. You are asked to calculate the relative molecular mass of this compound. The relative molecular mass of this compound is simply the summation of the relative atomic masses of the individual elements that make up that compound. So what that means is we'll be adding the relative atomic mass of calcium plus the relative atomic mass of carbon plus the relative atomic mass of oxygen. But if you check very well, we have 3 besides oxygen, right? So 3 atoms of it. So we'll be using 3 to multiply the relative atomic mass of oxygen. That will give us the relative molecular mass of this compound. So let's go. Calcium will be the relative atomic mass of calcium is what? So we'll be looking at relative atomic mass of calcium, that of carbon, and 3 times that of oxygen, right? So the relative atomic mass of calcium plus the relative atomic mass of carbon plus 3 times the relative mass of atomic mass of oxygen, because of these 3 here. So that will give us the relative atomic mass of calcium is what? 40. So we'll be having 40 plus that of carbon, we're giving us what? 12. So we'll have 12 here plus 3 times that of oxygen is what? 16. So this then means that we'll be having 40 plus 12 plus 3 times 16 will give us what? 48, right? Press your calculator, 48. Now 40 plus 12 plus 48 will give us what? If you press your calculator, you have 100, right? So we'll be having 100. But now, what is the unit? Because you can't just write 100. Relative molecular mass. We are looking at mass, right? So mass, the unit is in grams. So the unit of this is grams. So we can conclude that the relative molecular mass of calcium trioxocarbonate, that's limestone, is equal to what? 100 grams. 100 grams. So this is one way of solving relative molecular mass. Let's consider another example under this. All right, let's look at the second example. In the second example, we're asked to calculate the relative molecular mass of this calcium trioxonitrate. Now, if you look at this very well, just like in the first example we did, the relative molecular mass is actually the sum of the relative atomic masses of the individual elements in this compound. That means that the relative molecular mass here will be equal to the relative atomic mass of calcium plus that of nitrogen and oxygen. But if you look at it very well, these two outside the bracket here is affecting everything in the bracket. It means this 2 is affecting nitrogen and this 2 is also affecting what? Oxygen, right? So this will be the relative atomic mass of calcium plus the relative atomic mass of nitrogen, but because of these 2, we'll be having 2 times the relative atomic mass of nitrogen. So we'll be having 2 times N, then plus that of oxygen. We already have 3 here, and this 2 is also affecting this. So we'll be having 2 times 3, which is what? 6. So we'll be having 6 times the relative atomic mass of oxygen. So the relative atomic molecular mass now will then be that of calcium. Relative atomic mass of calcium is what? 40 plus 2 times the relative atomic mass of nitrogen is what? 14 plus 6 times that of oxygen is what? 16. So you'll be having 40 plus 2 times 14 will give us what? 28 plus 6 times 16 will give us what? 96. So if you add up everything, 40 plus 28 plus 96, using your calculator, you have what? 164. But remember, I told you the unit is in what? It's in grams, because we are talking about mass here, relative molecular mass. Hence, the relative molecular mass of this is 164 grams. So with these 2 examples, you can see how to calculate the relative molecular mass of any compound. So using the first method, the first example and the second example, you can always calculate the relative molecular mass of any compound. All right, to prove that you actually understand what we are doing, I'll leave this as a classwork. So you have to solve this and drop the answer in the comment section. Calculate the relative molecular mass of sodium trioxonitrate. Now, sodium was given as 23, nitrogen as 14, and oxygen as 16. So you have to calculate this and drop your answer in the comment section. I will see you in the next video. If you've not subscribed to our channel, please click on the subscribe button and subscribe so you can be seeing contents like this.